Hello everyone and welcome back to another exciting video of the Hidden Quantum Champion series. Today we are looking again at a Chinese company, this time at one that is building neutral atom quantum computers. Within China, the company is called CAS, Cold Atom. And if you want to learn more about them, and if you also want to see how they compare to other players in the field, or mainly I will compare them to one player in the field, then stay tuned for today's video because we are diving deeper into CAS cold atoms. And with that, as per usual, get yourself something to drink and get comfortable as we are diving deeper into the company. And with that, let's jump right into it. So here we are on their website. It says up here, CAS cold atom. You see also the Chinese name. I cannot read that one though. And in the background, you can already see the products. So the quantum computer. They sell both the quantum computer and there's also some computing cloud platform access, so you can also run stuff on the computer that they have. They also do have other products in the domain of quantum sensing, I would say, like quantum gravimeters and so on. We will briefly look at those later on, but for now let's only focus on the quantum computers. So let's quickly jump into it right away. So here we are on the products page, and there are different products. I mentioned that already. So quantum computers, quantum precision measurements, quantum sensors, and then quantum measurement and control. And this is actually not untypical. We've seen this with other players in the field as well, that they not only sell, let's say, the full system as in cloud access, but also the hardware system as in the computer, and then also the elements that go into it, like, I don't know, we've seen in trapped ion cases that they might be selling the ion traps themselves or the laser systems. We've also seen for superconducting systems that they might be selling the chips and the electronics, the cabling and so on. So this is not untypical. And then also derivative products of it, like, for example, the quantum sensors. But we are for now interested in the quantum computer, which is called Hanyuan-1. I hope I pronounced that correctly. Sounds like a rhyme. And let's jump into this one. So it says atomic quantum computer. Let's see. Here it says Hanyuan-1 features a cabinet design comprising a physical cabinet and two circuit cabinets capable of operating in standard indoor environment without the need for a cryogenic system. It is easy to deploy locally, offering high adaptability, high stability, good security, and high integration. And I mean, if you look at it, it looks like it's something that you can probably put into a typical server system. So you have these standard rack sizes that also go into supercompute centers, and then next to it, this cube here where I guess the magic is happening inside. Yeah, that's the system, and it says Hanyuan-1 is the first atomic quantum computer developed by CAS Cold Atom Technology Co. Limited. It uses single atoms cooled and trapped by lasers as quantum bits with a quantum bit count exceeding 100. It employs microwave-based single qubit quantum gates with fidelity greater than 0.999 and has the capability of multi-qubit entanglement and arbitrary qubit connections. It is suitable for both global control quantum simulation and circuit-based quantum. Hanyuan-1 features a cabinet design comprising a physical cabinet and two circuit cabinets capable of operating in a standard indoor environment without the need for a cryogenic system. It is easy to deploy locally, offering high adaptability, high stability, good security, and high integration. That's what we saw before. So basically, yeah, the system comes with what they say 100 qubit count or exceeding 100 qubits. I'm not sure if this is like physical qubits, logical qubits, if this is atoms that are sitting in the system. That one we don't know yet. But it says, you have more than 100 quantum bit count. And what is interesting is the fidelity here, which is greater than 0.999. And we will look into that in a second and compare this number. But first, let's learn a little bit about the technology behind this. So the Hanyuan-1 is a rubidium-based computer. So it uses rubidium atoms, to be more precise, the number 87 rubidium atom. To do its computations. And here again, it says number of qubits is 100. number of tweezers is 200. So these are the optical tweezers. You see here the microwave control of 200 atomic qubits results in coherent radio oscillations between 0 and 1 state, with all quantum qubits exhibiting good consistency. And then, you see here the single qubit fidelity, which is greater than 0.99, coherence time T2 time larger than 100 milliseconds, and you see other metrics here as well, like the 2 qubit fidelity. So when you operate on 2 qubit logical gates, and so on and so forth. Down here, I think is the interesting bit. So it says uses the randomized benchmarking method. The single qubit control fidelity was calibrated to be 0.99977. And there's also a link here. Well, maybe not. I don't think there's a link here to the publication where that comes from, but that's basically the data that they are looking at. Now, that is a fidelity of 99.977%, if you want to calculate it in percent. Now, how does that compare to other players in the market? I don't want to do a full overview now because that's not my job here. I just want to, let's say, point a little bit of a reference, as in, are we close compared to other companies? Is it better? Is it worse? Basically just giving some reference point. And I looked it up, and basically the company that I wanted to look at is Inflection. This time I'm pronouncing correctly the name of the company, unlike in the actual video that I made on Inflection. And well, I mean, here is the current website of Inflection, what it looks like. So Scale with a Q is the product. We are in 2026, and the 2025 product is what can be bought now, what is available. There's an upcoming one also presented here. And here we see that the fidelity, and I'm zooming in on that a little bit, representative ZZ fidelity is 99.48 with post selection, and then the raw one is 98.8%. So 99.48 versus what we've seen before as a CZ fidelity in this case here. Where is it? Well, it just says F here, but I assume that I thought it was somewhere also saying CZ as a comparison. But well, the fidelity that is being pointed out here is 99.977. Now, does it mean that the fidelity of this system here is better? Does it mean the other one is worse? I don't want to comment on that, because there's also always a lot of, let's say, more information that goes into it. Also take into account that here we are talking about rubidium atoms, while Inflection is using cesium atoms. So these are also available here in this customized branch. But these are things to kind of consider, to take into account when comparing these two things. So it's not like we can just compare the numbers right away to each other, but it is just to say, like, it is a, let's say, pretty, a pretty competitive system. Let's say it like that. And there's more information in here. I will not go through all of the details of that one now. If you want to, let's say, share a little bit more of details on that, if you're an expert in the field, if you are following the research and the publications on that, please let us know down in the comments below. I'm always interested in your opinions and also interested in the discussions. Then we see here what let's say the system setup looks like. So you see these two racks here and then the rectangular box. What is actually inside? Well, on the one hand, we have all the electronics, right? So we have drivers, radio frequency source, ion pump controller, microwave system. So basically all the signal generation. Then we have more signal generators, Rydberg laser controller. So that's for the Rydberg states that are being used in order to entangle, for example, atoms with each other, and that controls the laser of that. There's the optical tweezer system and other optical modules. And then within, let's say, this cube system, we see that's where the magic happens, right? So here we have the high precision integrated optical modules, temperature control chassis for ground state manipulation lasers, the main physical system. So that's where the atoms sit and where basically the manipulation happens, and a frequency locking system based on ultra scalable cavity. Then we have some dimensions here, so you can immediately see if it fits into your supercompute center, and some product features listed here as well. so can operate in standard environments, no cryogenics needed, suitable for quantum algorithm research. All quantum bits have identical performance with low coherence time. That's because they are atoms, right? So they're all identical to each other, can operate continuously, and can be transported over 800 kilometers without failure. I think that comes from a customer project that they had, or a deployment project that they had, and compatible with standard cabinets, easy to deploy locally and transportable. Applications are combinatorial optimization, quantum simulation, quantum finance, pharmaceutical and chemicals, high performance computer and quantum computing hybrid, and machine learning. These are cases that we've seen also with other companies from, let's say, the quantum computing field being pointed out. Then there's some information about the company and some way to contact them. I guess also with some WeChat code as well. Good. So that's about the quantum computer. Just for you to see the reference, I will also quickly go through the other products just so that you've seen what else they're selling, right? So there's the high precision, let's click on that quickly, the gravimeter. So high precision compact absolute quantum gravimeter. The atomic absolute gravimeter is a novel quantum gravity sensor that uses lasers to manipulate the interference of free-falling atoms in ultra high vacuum chamber and extracts absolute gravity acceleration information from these inference fringes. So you're basically using, let's say, the interference of atoms with themselves, which is very precise, because let's say the wavelength of the atoms themselves is very, very short. You basically let them fall and then interfere with themselves, and thereby you can extract some you can extract the gravity, you can extract the acceleration that they feel towards the Earth, which is the gravity, and that's basically the measuring mechanism. There's some more explanation in here. So you can see the atomic absolute gravimeter is a novel quantum gravity sensor that uses lasers to manipulate the interference of free-falling atoms in an ultra-high vacuum chamber and extracts absolute gravity acceleration information from the inference fringes. Compared to traditional absolute gravimeters, atomic gravimeters have no mechanical moving parts and can perform long-term continuous gravity observations. Now, that to say there is no drift, right? Because you're measuring with atoms. It's not like the property of the atoms is changing in any way, right? So you will not see any electronic drift or something in the atoms themselves, maybe in the measurement electronics though. But usually that means these devices are not only precise but also stable over a long period of time. So they're also suited for long-term measurements. And if you have, let's say, moving vehicle, helicopter, submarine, then it might be interesting to keep them up and running for a long time. So the key technology of the atomic gravimeter developed by our company comes from the cold atom physics team of the Innovation Academy for Precision Measurement Science and Technology, Chinese Academy of Science. The team developed the first domestic quantum gravimeter in 2010, a portable gravimeter in 2017 that participated in the 10th international comparison of absolute gravimeters, and a miniaturized atomic gravimeter in 2019 that was included in the catalog of independently developed products by the Chinese Academy of Sciences. This quantum gravimeter model WAG-H52 has reached an internationally advanced level in terms of volume, weight, power consumption, and gravity measurement accuracy, and has successfully participated in the 11th international comparison of absolute gravimeters ICAG 2023 held in the United States. Product features: fast response, long service life, high precision, so 15 microgal per square root hertz. We've talked about these units before, so if you want to, let's say, understand this a little bit better, please check out the Hidden Quantum Champions playlist. There's a video of a company that is working in the field of quantum gravimeters as well. So Micro Galileo is probably something that you might want to look out for otherwise. Long-term stability. And then we also see easy to operate, comes in 5 packaging boxes and so on and so forth. There's some product specifications down here and installation and measurement data available as well. The other products are basically, let's say, related to this. So we have the quantum gravimeter, which is basically similar to this absolute gravimeter here. And then we have the gradiometer, so atomic gravity gradient meter is based on 2 atomic gravity meters placed vertically or horizontally to measure the gravity gradient value. That is basically measuring the change of gravity as a function of distance between those 2 gravimeters. And okay, here we are also moving into Chinese now to explain how this technology actually works. But I like the fact that here on the website they're also explaining, let's say, the technology that is behind this, or the reason, the physics reason why that actually works. I think especially for sensors, this is a very nice thing to have. And on the control side, so you see there's like laser controls, mechanical shutter driver, acousto-optic modulation driver. We've talked about acousto-optic components as well in previous videos, and high precision digital pulse delay generation, and so on and so forth. So these are all components that then go up in the integration into the whole systems. Now quickly, maybe before we go into the About Us tab, just quickly checking on the news. So I'm recording this beginning of 2026. The latest news that we see here is from 2024. Let's quickly check if this is also the case for the Chinese version of it, just to make sure, because sometimes not everything gets translated. Now we don't see anything. Maybe, because it hit me back to the previous page. So in the news section, we see there's 2026 news available here as well. So at some point it was just not maybe translated anymore. Here it says quantum force empowers geodesity, Songye Kuyuan debuted, and so on and so forth. So there is some activity ongoing. I'm reporting this in April of 2026, and I mean, here's news from April 2026. So there are things happening. Let's quickly just jump into this just to see what the news are about, the latest one. So from April 17 of 2026, co-sponsored by the Geodetic and Navigation Professional Committee of the Chinese Society of Surveying and Mapping and the Chinese Committee of International Geodetic Society, and undertaken by the Central South University, the 2026 Comprehensive Academic Annual Conference for Geodesy and Space-Time Information and Geodetic Surveying Research. The meeting was successfully held in Changsha, Wuhan province, as a supporting unit, and so on and so forth. Event with its core pragmatics and cutting-edge solutions in the field of quantum computing, measurement, and quantum measurement control. So we see they have been exhibiting their technology there, and I mean, there's much more information in here. I'm not going through all of these details for now, but you see they're like actively still, let's say, distributing this information or participating on events. Let's quickly jump back on the company as per usual. So you see there's also a cloud platform up here. Let's quickly jump back on the company. So company introduction, CAS Cold Atom Technology, based in Wuhan, founded in 2020. It was listed as a national high-tech enterprise in 2022. The company's research and development team focus on Innovation Academy of Precision Measurement Science and Technology, CAS, China. Our team is one of the first teams to start the research on quantum technology of neutral atoms in China. We have 2 chief scientists of National Key and R&D Program, 3 candidates of the National Youth Talent Program, and over 20 postdoctoral students. We have published over 300 high-level articles, including Science, Physics Review Letter, and so on, and nearly 100 patents. It is the first team in China to possess both quantum computing and quantum precision measurement research and industrialization capabilities. The team is the first action of similar international research in the fields of atomic interferometry, precision measurement, neutral atom quantum computing, and other research fields, and has profound technical accumulation in the fields of characteristic advantages such as quantum precision measurement, quantum computing, quantum measurement, and control and application. There are some corporate values here, vision, values, and goals. So accelerating the quantum revolution with cold atom, integrity, altruism, positivity and integrity are the values, and the goal becoming an internationally leading provider of quantum technology. And part of that is, of course, to also get international awareness. And this is also what this Hidden Champion series is about, right? Like shining the light on all the companies from all over the globe that are working on quantum technology. Quickly on the development history, so founded in 2022 in Wuhan, and the angel investment round also started there. Then in 2022, we see there's this Series A funding and December Wuhan Quantum Computing Innovation Center. Then in 2023, we see there's a lot of stuff happening here. And then in 2024, first quantum gravity delivered, and then atomic computer in China, Yuan 1 released. There's also some honors here, honor certificates. I can't go through these because they're all in Chinese. And that's basically what we can see here about the company itself. That was everything I wanted to share with you for today's video in CAS about CAS called Atom. I hope you found it interesting. So you see that, let's say, at least on the first side, I will not go into the details for this series, but at least on the first side, we have a competitive company that can internationally compete with other players in the space. Very interesting. I'm also interested in your opinion, and I would like to have a conversation also down with you in the comments below about what technologies you find interesting, what you want to learn more about. I'm always excited to also learn from you. So if you have other information that you want to post down there, just feel free to share. If you don't want to miss out on the next video, make sure to subscribe to this channel. I'm looking forward to see you again. Until then, bye-bye.